All right, everybody, welcome back to another Ask a Dev Unreal Engine live tutorial because, these always go fun. Why not do it live? Why not stumble through it without any kind of ability to edit the videos? My name is Kevin. What's up, Josh? Welcome to the stream. What's up, everybody? Thanks for hopping in. We try to do these once a week. I currently work as a senior principal tech artist at Riot Games, but this is an amazing chance for me to learn a ton of stuff about various things about Unreal Engine and every aspect of the engine based on your questions and your requests. So speaking of that, quick shout out to two of our newest Patreon members, Humko and Mr. Dirty Daniel. Thank you so much for helping support the channel. Off the rails, welcome back to the stream. Today's stream is nuts. Y'all, this flying pets thing is kind of crazy. So this is probably going to take us a couple of sessions, so let's kind of hop in and get going. The way this works is I'm going to roll through the tutorial, and if you have questions about what I'm doing along the way, feel free to shout those out. I'll try to keep track of the chat as the actual chat windows as I go. And but if you have general Unreal questions or any kind of super chats or anything like that, I will hang out at the end and answer some of those so that we can make sure those are all covered. With that, let's get going and hop into Unreal. So theoretically, here we are in Unreal Engine, and we have, if you all recall, we have our pets. Our drone in particular now has a flying and a blueprint, and we can move it around, etc. That's all great, but wouldn't it be cool if when we weren't possessing the drone, or the pet, whatever it happens to be, it could move around and do its own thing? That's what we're doing today. We're going to build out its behavior trees. We're going to make it so that it can follow us around the map, and there's some fun challenges to that. As it turns out, I'm going to show you what some of those stumbling blocks are as we go. So with that, let's hop straight in. In order for our drone to be able to follow us, we need a behavior tree. We need to be able to give it behavior. So let's just start with the behavior tree. So from an artificial intelligence window, we're going to choose behavior tree. I'm going to call this behavior tree drone. Let's call this live drone so that I know I'm looking at the right one. Live drone. And for those of you that are new to behavior trees, let's pop this up open over here. Basically, we have an intro to AI series that you can kind of look through, but basically this is the tree that makes the decisions of what this character is going to do next. Now, before we can get started, we do need a Blackboard for this behavior tree, so I'm just going to go ahead and click on new Blackboard. And does it crash? Is that how we're starting this? Ooh, maybe. It's thinking hard. Oh, no. Whew. Thank you. So this is going to be Blackboard live drone. Okay. Man, it is thinking hard about that. Okay, so quick recap. The Blackboard allows us to store variables that the artificial intelligence will use, the AI will use, all throughout this decision process and everything. So we have a behavior tree, we have a Blackboard. Let's just keep this simple to start with. Let's just try today to get our drone to follow us around the map. So to do that, we're going to need a MoveTo location. So let's go ahead and create a new Blackboard key, and we'll call this MoveTo location. All right, so taking a step back, we now have a place to store where we want our character to move to. And really what this is going to be all about is it's going to be all about getting our character to go there. So first thing, let's just test this. Let's just see what happens. If we drag off of our route, let's create a sequence. This is, it's going to execute everything that it has underneath it in order. Let's just do a simple MoveTo. And then when we're done with the MoveTo, we are going to wait for, let's say, 2 seconds. All right, let's make this simple. How do we determine where we're going to move to in this MoveTo actor component? Well, what we can do is over here on the right, when we when we look at where we're moving to, we can move to either an actor or a variable. In this case, we're going to move to our MoveTo location. So right now, all this does is every 2 seconds, this will move to the MoveTo location. Now, how do we set the location the drone is going to move to? Well, in its simplest state, what we could do, for example, is we could, in tick, if we wanted to, I don't want to do that in tick. Let's not do that in tick. Let's just set this value to be, oh, I thought I was going to skip this because I thought we were going to show you the simplified case, but we're not going to skip it. So we have our move to, we're telling our drone to move to somewhere, but when we play, there's going to be a couple things. First off, our drone's not moving, nothing's happening. There's a whole bunch of couple things that we missed. So first off, even though we've created a behavior tree, we have not told our drone to use it yet. So let's go do that. So in our drone, what we're going to do, this is, oh, that's pet base, hold on. We could do it here, but let's just do it in the drone for now. So in our drone blueprint, I'm going to open the full blueprint editor. I'm going to add a begin play, and on begin play, what I am going to do is I'm going to tell this drone to run that behavior tree. So what I'm going to do is I'm going to get the controller for this character. I'm going to cast it to an AI controller just to be sure. And if that succeeds, then I am going to run the behavior tree. And the behavior tree that I'm going to run is going to be our live drone one, so that we're doing this. So now what's going to happen is on begin play, the drone is going to run this behavior tree. The behavior tree only does two things. It moves to a location and it waits. Currently, our default move to location is 000. So this drone theoretically would run to 000, but it's not even doing that yet. However, if we look, you can see that our behavior tree is working. So why isn't our drone moving? Anybody? It's because hopefully it's only this, but if you watched our behavior tree tutorials, there's nothing that tells this drone where it's allowed to move yet. So we need to define the Nav Mesh Bounds for this AI so it knows where it's allowed to go to. So in order to do that, what we need to do in our level is we are going to add a nav, I'm just going to type it here, nav mesh bounds volume. Okay, so wherever I put this in my map, this is where the AI is going to be allowed to move to. Let me get this up here so it overlaps the floor. And the easiest way to visualize this is if you press the P key, anywhere that is green, your AI is allowed to move to it. Well, right now we need to expand this out significantly so that our character, our enemies, or not our enemies, our pets in this case, but this would apply to enemies as well, can move anywhere on our map. So I'm just going to make this a little bit bigger. Okay, and you'll notice that when I do that, scale it up. So it covers the platforms, it covers everything. So everywhere green, the AI can now move to. That's where it knows how to get to. So now if we press play, does it move? Doesn't seem to be moving. Why is that? Well, let's go back and see what our move to location is. I'm going to go ahead and move this up. And we will check to see our move to location. Acceptable radius is 5, and the default value is a vector. Oh, it doesn't have a default value. Interesting. Okay, so let's set that. Let's set it to, let's do something new in our behavior tree. All right, let's create a task. So each of these are called tasks. Okay. Now I'm glossing over some of this because you can always go watch the intro AI to get the more fundamental understanding of what these things, but each of these things in the behavior trees are tasks. These are predefined tasks, but we can also make our own. So let's make a new task, and Oh, it's not going to let me do that. I don't like it when it does that. For some reason, if it's already created, it's not there. So let me try this. Task. Nope. So here's what I'm going to do. I'm going to duplicate one of these tasks, and I'm going to copy it over. I'm going to copy this task over to our AI folder. And then what we'll do, for the sake of the demo, so let's just blow all this away. And let's rename this task to be, we're going to call this MoveTo random location. Just to get our AI moving. All right. So Trello Skills, welcome to the streams. Looks like you need to tell the drone not affect the navigation under it, under the camera. Instant isn't green. That's a really good question. So Josh is pointing out a really good thing here. Right now, our drone, wherever we put it, you'll see the Nav Mesh updates, and you can't technically move there. In general, this isn't necessarily a bad thing when you have characters that are on the ground, but because this is a flying character, to Josh's point, we might want to consider updating this character so that it doesn't affect Nav Mesh Bounds. I'm not going to do that, but just so you know that where it is, if you go to your blueprint and you do a search for Nav in the details, you'll see that there's going to be different items as part of your character. For example, the capsule. If this can ever affect navigation, that area underneath the character will be unnavigable by other AI in the game, for example. So it's possible for a flying character you don't want this. I don't know. It depends. But if this, so really good call out. Thanks for that, Josh. Depending on what kind of pet you're making, if it's one that's on the ground and you don't want your characters to step up on it or anything like that, you probably do want to affect the navigation mesh. If it's a flying character, you may want to choose, but at least now you know where this is. And keep in mind, you probably may need to check each of the components that are underneath here, because the pet base doesn't, but the capsule does, the static mesh does, the skeletal mesh doesn't. So you'll have to go through and you'll have to check each of these things to make sure it's not affecting the Nav Mesh Bounds. All right, so let's go back to our MoveTo random location. And what we are going to do in here is we are going to add an event, and the event is going to be, let's see here, event, or let's just choose one of these overrideable ones. Receive, execute. All right, so this receives the execute. That's tells it to do something. We're gonna get the owner actor. Let's get the actor location. Get the actor location. That is the scale. Let's try that again. So we're going to get the actor location, and then we're going to get random location and navigable radius. And the origin is going to be where the drone is currently. Let's set the radius to about 500. Okay. And then with that random location, what we want to do is we want to use that to set our MoveTo location. So let's get the Blackboard for this character. Let's get the Blackboard. Get the owner's Blackboard. And with that, we are going to set a vector value. And the vector value that we are going to set is going to be the result of our random location. Okay, and then we need to set our key name here. All right, so let's make a literal, and the key name is going to come from our behavior tree Blackboard. And I'm just going to copy this just so I don't get any mistypes. There we go. So what's going to happen is in our behavior tree, we are going to do that was called BTT MoveTo random location. All right. So what's going to happen in our behavior tree is it's going to start, it's going to go into the sequence, and it's going to move to a random. It's going to, actually, let's rename this. This is very deceiving. This is not MoveTo random location. This is find a random location. find, just to be clear, so you all, so this is clear in y'all's heads. And then let's delete this and do find to random location. That's close enough. Find random location. Then this is going to move to the MoveTo location, which is set by our find location, and then it's going to wait for, let's do 3 seconds, for example. Okay, so theoretically, this should work. Now, we do have one problem. We need to, in all of our executes, we do need to return whether or not it was successful or not. So I believe that is return or finish. We need, it's called finish execute. And when we're done, we want to say that it was successful. The reason we want to say it was successful is because if it's not successful, what it does is it quits out of this entire sequence and goes back to the beginning. So what would happen is it would just basically loop from root to sequence to location, back to root to sequence to location, never continue on. So we have to make sure we check successful. So let's go ahead and save this, compile and save this. Drone should be good. Let's compile and save this, and then I'm going to show you one more potential problem. Okay, cool. So every 3 seconds, our drone should move to location. Now, I know this looks funny. Twitch. Bobo98, what's the, welcome to the stream. We do have a Twitch stream going at the same time, yes. Okay, so I know this looks funny, and you all are like, that is a stressed out drone. But the cool thing is, it is moving, which is great. Now, we have a lot of tweaking to do to get this to work the way we want it to, because what we really want to do is we want to choose a random location around our character. And we're also going to start to talk about some of the problems and how to fix this freak out that's happening as part of the MoveTo. And it turns out y'all's question was a tough one, because this whole flying AI thing does a lot of weird stuff. So we're going to try to fix a bunch of this stuff. So basically, this MoveTo is it's pretty basic. We have our allowed pathing. We can observe a value, we can do all these kinds of things, but the actual way this move is being done is it is triggering our input in a way that is not smooth and doesn't look great. So what we are going to do is we are going to build our own MoveTo. But before we do that, let's update our find random location. Actually, we're not even going to update our find random location. We're going to replace it. So let's just keep this around for a good measure. So let's go back to our content drawer, and what I'm going to do is I'm going to duplicate this, and I'm going to find random location by owner. And by owner, what I mean by that is the pet owner, to be clear. I'm also going to rename this to find random location. Okay. That way we have the 2 different ones if we want to test something. And then all we need to do is we need to update our by owner to be, rather than getting a random location around myself, what I'm going to do is, and there's a couple different ways that we could do this. One thing we could do is we could take the owning actor and we can cast it to, actually we're not even going to do that. Let's just keep this simple. Let's get the player. Let's get the player controller. And with the player controller, we can get the, can we get the location on this? Is that going to give me, get the actor location, and we'll use that. All right. So why did I do this? Again, I'm going to talk through why I'm doing it this way, but there's probably a better way. And why is there a better way? This is getting the player controller, which is, if you only have a single player, works, because it's the only person who's playing locally. If you have a multiplayer game or a network game or any of those kinds of things, this can get funky because it's only getting the index 0 player. Assuming that the person playing is the index 0 player, this is going to work for the purpose of the demo. For an actual implementation, there's a few things that you could do better with this particular case. One is you can, when pets get, depending on how your setup is done, when pets get assigned to a player, one of the things you do with the pet is you set a value for the player that its current owner, and then what you can do is you could cast to that pet here to get the owner. You could use blueprint interfaces to find the owner. You can simply on the pawn create a variable for the owner when the pet gets created, etc. There's lots of things there where you can get around this, but for now, for speed, we're just going to do it this way. So we're going to get a random location around this, and what I'm going to do is I'm actually going to store this as a variable. I'll show you why in a second. Okay, and it turns out we already have a variable, so let's, oh no, don't crash. It froze. Okay, so let's delete this, and let's delete this, and then let's set our random location. All right, the reason that I am setting the random location as a variable is if I want to use it later, anytime it reads this pen, it will get a different random location. So the one that you get to set this random location would be different than the one if I plugged it in here too. That would be two different random locations. So in general, the way randomization works, I like to store it as a variable so I can use it later. The whole reason I wanted to do this in this case was because I want to visualize where this drone is moving to. Mr. Dirty Daniel, welcome to the stream, and thanks for your support on Patreon. All right, so what we're going to do is let's draw a debug sphere for this. And where we're going to draw the debug sphere is we're going to draw it right here. The reason I did this is because if I had connected off this, the debug sphere drawn would have been different than the value that's being set here as the vector. Let's set this to a radius of 50, for example. We'll make it a nice pretty blue, and we will, something is chugging. Duration of point, sure, let's just use 1, thickness of 1. Okay, compile. Now, in our behavior tree, rather than finding a random location, we are going to find a random location by the owner now. And what this should do is it should print out where it's going to. So we can see the blue sphere. There we go. So it's trying to get to where I am. So wherever this happens to be, that's where it's going. And it's looking within a certain radius of the owner. So when I move over here, the drone's going to take a few seconds. You'll see, whoa, oh, okay. Very important point. Why is it still moving around? And this is exactly why we printed out these debugs here. Why is it moving around over there? It's moving around over there because that's where the controller is. So let's go back to our find random location around owner. And rather than getting the controller, let's get the control pawn, and let's get that location. And let's try that exact same experiment again. Okay, so now it's moving towards me, right? It's finding random locations around me and doing it. Now, you'll notice our drone never goes in the air. And it's also still doing that just awful breakdancing flipping thing, which is a whole other can of worms. Like I said, you all picked a hard one for this, okay? So that's good. We have our random location, but what we want to do is our drone should probably be in the air. So let's just expand on this a little bit more. Here's what we're going to do. We are going to, let's move this out. What we're going to do is we're going to take this random location and we're going to split it. Yikes. Let's split this. Yeah, let's split this pen. Not a spline point. Let's right click, split the struct, okay? And what we're going to do is rather than using the Z value, remember Z is up in Unreal, okay? We're going to randomly generate a Z value. So here's what we're going to do. We're going to set our random location. Oops, I missed that. And what we're going to set it to, let's split this pen struct. We're going to set X to be X, Y to be Y, and Z, rather than setting it to the Z value, we are going to set it to, apologies, we're going to create a random float in range, for example. And let's just say that our minimum range, we want it to be at least 50 units off the ground and up to, let's say, 250 units off the ground. So now what this is going to do now is it's going to find a random location, and then we're going to override the Z value of that random location to get our drone up in the air. So it actually looks like it's flying, and it's going to vary based on a random float each time. So it will go to different heights somewhere around us, theoretically. This actually isn't going to work. Now watch it works just because. Okay, so you'll notice that when it goes to fly to that location, it's not actually going vertical. Even though the sphere is clearly in the air, it's not going vertical. And this is largely because, let's see, are we actually setting our MoveTo location? We are. This is because, turns out, AI doesn't know how to move off of the nav mesh. So, in order to do what you all want, we actually have to implement our own movement. Which means we are going to replace this MoveTo. We're going to take this out. All right, so how are we going to do that? Okay, so I fought with this a couple different which ways from Sunday, and we're going to solve two different, kill two birds, one stone here. And what we're going to do is hopefully fix our breakdancing drone issue, as well as solve our it doesn't actually fly to the point. Now what's interesting is this point, I actually thought that it wouldn't even move to that point because it can't actually get there. Let me just double check that one more time. Yeah, and it's using a radius of 50. So, whoa, where's it going? Oh, and that's the other thing. Did you see how the drone went there? It goes down the stairs, it goes around the corner, down the stairs, and back out again. We are using floating pond movement, interestingly enough, Josh. So our base pet uses floating pond movement. So anyways, these are all really great questions. So floating pond movement only helps in the movement, not the navigation. As far as can the nav mesh be 3D or 3D cube, not that I'm aware of. And if you are an Unreal guru, and not any way that I found without additional programming. So we're going to solve this just by opening up the entire 3D space. Now, if you are a navigation Unreal Engine AI guru and you know of some 3D nav mesh that I don't know about, please throw it in the comments, man. Help the community out. We'd love it. So in the absence of that, what we're going to do is we're going to go through a fun exercise of moving our character ourselves. So let's do this. Let's simply take we're going to do this on tick. And what we're going to do is let's just get it working first. All right, so let's add event, and we'll decide. We'll have a discussion about whether tick is the right place to do this later or not, etc. What we're going to do is we are going to for our self, we're going to get a self reference. We're going to get the controller, get the AI controller actually, get the AI controller, and with the AI controller, we're going to get the Blackboard, because we still want to use the tree to move our character. And with the Blackboard, we're going to get the value as a vector. And the value that we're going to get is the same one that we're setting in this random. So I'm just going to copy paste this, Control C, Control V. Okay. And what we are going to do with this is we're gonna end up doing this a couple which ways from Sunday, just so you can kind of see how the stumbling goes, the progression. Okay, let's just do it the harsh way first. What we're going to do is let's set our actor location. This is not what we want to do. And the reason this is not what you want to do is because, as most of you, or a lot of you have probably guessed, this is going to snap our character to the location. It's just going to pop there. It's not going to actually fly there. Something is going on. Oh, it crashed. It did crash. I was hoping it wasn't going to do that. All right, let's go. We got to bring it back. Unreal Engine, library. Hopefully this will help with our churning speed. Basically what's going to happen is if we just set the actor location, when we get a new location every 2 seconds, our character is just going to pop to wherever the location is. That's not really what we want. We can try this restore, but my experience has been that this has not been working lately. Yeah, I couldn't. Okay, that's fine. Okay, so here we are. Let's bring this back, and let's bring back our large font so that you all can read this a little bit easier. And then let's take a look and see how much we lost. So what we're going to do, would a lerp node help smooth out the movement? Yes, Josh, that's exactly what we're going to do. So in our pet blueprint, let's see how much we lost here. All of it. Awesome. Okay, so let's do that again. It's always easier the second time, right? Let me bring my notes back up though. Just so that we can hopefully move through this. Oh, are you kidding me? Well, y'all, this just got interesting. It seems as though I lost all of my notes as well. Let me just double check this. Okay, this is gonna be fun then. All right, let's go. We got a lot of work to do, y'all. This just got hard. So let's go. Tick. Let's get our let's get self. And with the self, we're going to get the AI controller. And with the AI controller, we're going to get the Blackboard. And then we're going to get the MoveTo location value, get the MoveTo, get value as vector. And with the value as a vector, the key name we're going to use, let's make this. How did I not save that? You gotta be kidding me. All right, so this one is going to be back in our behavior trees. Find random location by owner. Let me dock this over here. This is the one we want. Let's plug that in. Okay, and let's compile and save this. Let's set our actor location. Set the actor location, and we're going to set this to the actor location. Compile and save. And we play. Oh, is that going to crash again? Oh my goodness. Okay. Wow. I have an idea of why that's happening. Let's give it one more shot. It's going to be hard to do this if it keeps crashing. But this time at least we saved it. So here's what I want to do. In my pet blueprint for my drone, I have a sneaky feeling that what's happening is it's trying to move to a behavior tree that doesn't exist yet. So I'm just going to put a delay in here. I have a feeling. So let's put like a 1 second delay in here. Compile and save that. Let's see if we can even run without crashing. Okay, we did not crash that time. That's good. And our character is now snapping to the locations that are randomly around. Okay, let's go back to our behavior tree and see if we can't update this. All right. So let's get rid of this MoveTo. We don't need it. We need to plug back in our find random location by owner. Save that, and now run again. So it's just moving around, popping based on wherever we are. It looks like we may have lost our vertical our verticality? We did. So let's bring that back real quick, because that's going to be an important part of what we're doing. And what we're going to do is we are going to set this random location, split these structs, connect them in, restore our random float in range, and we had said 50 to 250. Compile and save that, run again. Our character should be popping around. It is. It's popping around. Okay, so now that we are at least actually flying, now we got to make it so we're not popping. So Josh is right on the money with this. Let's go ahead and do this in our pets base, rather than just setting this value. We're going to lerp to it, but this isn't going to work either. And the reason, by the way, the reason I'm doing this is the natural progression. Like, this is how you would implement this. You'd sit down and try to figure it out. And then as you do it, you're going to hit all these stumbling blocks. That's part of this. That's part of this whole entire learning process. So how do we use an f-interpTo, which is or a v-interpTo in this case? So what we're going to do is we're actually going to get our controller. Or actually, yeah, we can just get our actor location, I believe, because this is our pawn. Okay, so this is our current position, and what we're going to do is we are going to v-interp, v-interpTo, interp. Hold on a second. v-interpTo. All right, and the way this works is you give it where you currently are. Let me make some room here. Sorry, things are a little tight because the fonts are so big. This is your current location. This is where you want to go to. And then what you do is you set the delta speed, which is the current delta in seconds, and then how fast do you want to do the interpolation. So if we interpolated if we set it to 1, you'll notice that if we play now, compile and save all the way, where's our drone? So our drone is now moving. You'll notice that it moves smoothly now to each of these locations. That's pretty cool, right? So it is basically interpolating its way towards each of these locations. Now, it doesn't look like it's flying there yet. It doesn't look like it's doing any of the banking or any of the cool things that we would want it to do, but it is working. Now, if we change our interp speed, by the way, if we up this to 2, wrong button again. If we up this to 2, all right, let's go a little bit faster. Let's go 4. Now our drone is just going to move to where it's going to much faster. Now, obviously, that's a little too fast. And also, the other problem with it is you'll notice that the further it is, the faster it gets there. Watch, zoom, instant. But if I only move a little bit, it moves at a little bit more reasonable speed. So there's no concept of how far it's going or any of those kinds of things, but it is flying around, and that is already cool. All right, so rather than using interpTo, what we're going to do is we are going to try to set our character's input. So let's see if we can do this without the notes. I'm pretty sure. Pretty sure I lost it. Yeah, because there's no tick here. Bummer. Yep. We are flying blind, people. Stand by. This is going to be fun. Like I said, something always goes fun. All right, so here's what we're going to do. We are going to use the idea of setting the input on tick to hopefully get some of our flight abilities and feelings back. And that's going to work slightly differently. So basically, what we have is we have our current location, which is where we are. We have where we want to go to. That actually defines a vector. So let's see if we can't get the direction from where we are to where we want to go. This is using the get unit direction. All right. Now with this vector, what I'm going to do is rather than setting the actor location, what I'm going to do is I'm going to set my input of my movement component. I'm going to, I think it's set input. Is it on my input? Add input vector. That's what we want. Let's try this. Without my notes, I'm not sure, y'all. So this is going to be fun. All right, so we're going to add input. And what this is going to do is basically look at where we are, look at where we're going to, and every tick, it's going to add an input towards that position. So let's see what that looks like. Oh, look at that, y'all. Come on. That's cool. So we're basically forcing it to drive itself. Now, it's a little bit nuts because why? Because basically it is always trying to input something to get there. But you'll notice that as we move, the character moves to kind of stay close to us, right? Which is cool. And because we're forcing the input, what's happening is it's using all the flight controls that we built last time, which is cool. So that's great. Okay, now let's see if we can fix a couple of things in here. Let's go to our pet base and let's check to see if, well, let's make it so it's not so squirrely when it finally gets to its location. So because in the behavior tree, if we use the normal MoveTo, you'll notice that with that, there has an acceptable radius, whereby once it gets to a certain range, it will stop. So let's do the same thing inside of our little detection. So what we're going to do is we're going to get our actor location, and we're going to get the length, or no, let's get the distance, which actually is also a vector. And we're going to get the distance to where we're going. And if the distance is greater than 50, then we are going to add the input vector. So let's add in a branch here. And we're going to connect our tick into this branch. So if our distance from our current location is greater than 50, then we're going to add an input vector, meaning we're too far away and we want to get there. So this should hopefully help our drone settle down when it gets to its location, which it does. And the cool thing is, because of the way we set up our drone flight with navigation, or not with navigation, sorry, I've got navigation on the brain, y'all. The way we set up our drone flight with acceleration so that it all auto corrects, we get that automatic countering that's happening. So as the drone flies, it will kind of come and follow a little bit closer to where we are. Okay, so now it looks like our little buddy is kind of following us around the map. There's a couple other things that we want to try to do. And it took me a minute to figure this out, like a long time actually. So this next part might be interesting. So what we want to do is the same way that we have the unit direction for this. Right now our drone is flying backwards and strafing. It would be cool if it actually turned to face the way that it's going, right? So let's see if we can adjust that. But remember, the way our drone is set up is a little bit different. Our facing is done separately from our movement. Remember, our movement is based on input, and our look is done by adding controller yaw. So here's the thing: if we get this one's going to be a little bit different. All right, and I'm going to do this over here. I'm going to try to remember what I found after literally hours of digging. So if we get let's get our actor rotation. Get the actor rotation. Okay, this is our current rotation. So this is the way we're facing right now. What we want to do is we want to turn to the face we're going. So let's get, just like we did here, where we got the unit direction. What I want to do is I want to use this to make a rotation out of that. Because, so here's where we're facing. That's the rotation to where I want to go. And then to Josh's early point, I think what I did was I ended up lerping to that, but let's just try this. So we're going to do a rotator from X director. Rotate. Make rotation from X. Okay. So now we have 2 rotators. And what we want to do is we want to, I think we want to interp. Can we interp between these 2? Oh, yes, we can. We can basically rotationally interpTo. We do need our delta time. So let's plug this into our delta time. And let's do this over 1, just like we did before. And then can we just set our rotation? Not on the movement component, but I think we can set our actor rotation. Set the rotation. I spent a ton of time fumbling through this, you all. So I am not positive which one of these we need. But basically what we're doing now is, if we are not at our destination, we're adding our input to get there. And at the same time, we're also calculating what the look at is. So hopefully our drone will be facing. It will turn to face. It did, but it kind of snapped. Well, let's see here. It's snapping there. I'm not sure why it's snapping to face that. It's almost like our interpTo is. This is the unit direction from us to where we're going. This is where we currently are. And our interps, let's try cutting this down at 0.1. Is it that easy? Wait, that might have. I'm not buying that. That is not the behavior we want. That is still kind of snapping. So either our interpTo is not working, or this set actor rotation value. Let's see here. So we're adding an input vector. Let's just disconnect this, double check that it's not snapping. Yeah, it's definitely that setting that's doing it. Let's try something else. Let's take our controller instead. I want to double check. Set control rotation. Let's see if we can do that instead. Maybe we get better behavior out of that. I am totally making this up as I go now because I lost all my notes. So hopefully you all can see how a huge part of this is the stumbling aspect of it. Okay, so either our control rotation interpolation is too slow and we're not actually getting any changes, or that is not the way to go. So let's try 5. Nope, that's not it either. So setting the control rotation doesn't work. Can we add an input vector? Where's their yaw, y'all? Yaw, nope. From our controller, can we do the yaw? Nope. From self. Let's see. Or let's see what's available here, yaw. Add controller yaw input. Oh, that's interesting. Oh. This is definitely not the way I did it, but that could be a cool one. Let's just see something. Let's just see if we set this to 0.5. Does that change? I don't think that's changing. It is not turning. Okay. It's got to be the set actor rotation then. I swear that's what we did before. Let's do this. Let's get the current actor rotation and let's add. Nope, that's not the add I want. Let's add, or actually it's combined. For rotators, it's combined. I just want to see this working, you all. So let's add a 5-degree rotation over time, basically is what this is going to do. I'm trying to figure out if we're having problems with our interpTo or if we're having problems with the rotation. Nope, look at that. That's kind of fun. So when we get it right, it does work. We just got to figure out how to get it right. So currently the actor rotation is the current actor rotation combined with, oh, I wonder if we need to do, here we go. Let's try this. So our current actor rotation, hold on, is that all it is? Woo, that's not it. That's definitely not it. Okay, so basically we have our current actor rotation. Oh no. This is our target. And we're going to take our current, we're going to interpTo, oh, based on a value. Actually, this may be it. Let's give this a shot. Nope, that's not it either. There's another way to do this, y'all. So here's what we could use vectors instead if we are having issues with this, but we're close. It's something in here. So this is the unit direction from where we are to where we're going. So that's a vector, all right? Then we have we can get our current forward facing, get forward vector, okay? And then what we can do is we can take the two of these and we can get, hold on a second. Here's our forward vector. This is where we want to go to. We can do a vinterpTo. Let's change this. Let's flip this around, see if we can get this. VinterpTo. And we are going to be going to our facing, and we're going to be from our current. Our delta time is going to be this, and our interp speed of 1. And then from that, what we're going to do is we are going to make a rotator. Rotate. Rotation from, let's try a rotation from X, and let's just plug that in. Once we get this working, I can explain what's up. Oh, dude, wait, I think that's working. Okay, so let's increase our interpolation. Hold on a second. Let's go 5. Yes, look at that. It's turning to face where it's going now. Oh, thank goodness. Okay. Cool. Okay. Ambius Dotex. Just started watching. What are you trying to do? Make the drone rotate towards the direction that is about to move before it moves? Yes, that is correct. Okay, so we got it. Even without our notes, even in the debacle that was, we managed to figure out a way to get this thing to rotate. For some reason that our interpTo was not behaving nicely. Now, we do have a little bit of a funny thing that's going on with this, where when we're doing this, the rotation that we're getting is sometimes at an angle, but we only want the X and Y part of that. We don't really want the Z value. So I'm going to split both of these and see if we can cheat this. Let's go ahead and split this. I'm going to cheat this, and I'm going to see if we can just simply take X and Y and leave our Z as our character's current Z. So what this is doing, well, let's just see if it works, and then I'll explain what it's doing, because there's no point in explaining something that's not working. Yeah, that's better. Way better. Okay, cool. All right, so what's happening, y'all? Here's what's happening. Okay, so we are getting our current rotation, and from that we're getting a vector. Then we also have a vector of where we want to go, okay? And then we are going to take that and we are going to slowly over time interpolate between those two. So we don't just snap to it. With that vector where we want, so that generates a new vector. So let's say we're facing this way and we want to turn 90 degrees to the left. On the first frame, maybe we move about 10% of it. So we have a new vector that's kind of pointing at, let's say 10 degrees now. That new vector is how little we're going to nudge our character. So we're going to take that, which is the result of this v-interp2. Okay, we're going to take that and convert that to a rotator that we're going to plug in to our character rotation. But before we do that, we don't want verticality. We don't want the up and down. What we want is just left and right. So we're going to split that and just use the X and Y values. And we're going to take the current altitude that we're at, which is our Z, and use that as our Z. So what it looks like is this looks like it flies more like a drone, where what's happening is we are slowly turning over time, but we're also increasing our altitude, etc. But we're maintaining a flat pitch, kind of like a drone might do, for example, because a drone has vertical ascent to it. So all of this works pretty well to get our character to move around in a way that looks a lot more drone-like. Okay, now there is a lot of things. As we move, you'll notice that it updates to move with us and stops. If it is within a radius, okay, so what we need to do is right now our radius of acceptance around our hero is pretty small. So if we increase that, it will hopefully stop. Well, wait a minute. No, it's not. Okay, so now what's happening? Why is it flying all over the place? Well, actually, before we get into that, does anybody have any questions about that? Anubis does a similar thing with a timeline and a lerp rotator. Yep, that's awesome. Okay, so with this, why is our drone running around like a mad person? All right, well, the reason that's happening is in our behavior tree, every 3 seconds, it's finding a new location by the owner. And in our find location by owner, it does nothing to check to see where the owner is. It just finds a random location. But what if it's already close enough to the owner? Maybe it should just sit there. Maybe it would idle or do something else. So rather than always getting a random location, let's once again double check. Let's get the location of ourselves, of the pet at this point, the drone. So we're going to get the actor location, and we're going to get the distance to the owner. Okay. And what we're going to do is we're going to give ourselves some kind of threshold. Now, there's a couple ways. Let's just say that if the threshold is, if the distance is greater than, let's say if we're greater than 200, for example, that's 500. Let's do 200. Then we will try to find a new location. Otherwise, and I've got to show you how this works. So if we are further than 200 away from our owner, we are going to find a new random location around our owner, and then tick will move to that location for us. Okay, well, there's a couple things in here. We do need to finish this execute on false, because what's going to happen is if we don't, it's going to move there. And then once it actually gets within 200 may have been small. It keeps on going. Interesting. Why is that happening? I would have expected that to fail. Let's try 500. Maybe our radius is too big or too small. 500. We're getting our location. Or maybe we're getting the location of it. This is why we're probably gonna print another. Whoa, where'd it go? Oh, wait, come back, buddy. Where are you going? Okay, so that's a bummer. But part of the reason why that's happening is because I believe when we start off, we're already within 500 units. So it's, there we go. So now it comes to 500. Interesting. I am not expecting this thing to move anymore. Oh, there we go. Nah, hold on a second. What is happening here, y'all? Our drone is still moving. No, because we only want to update the location if it's further than, so Mr. Dirty Daniel is saying shouldn't be less than. So, okay, maybe I am thinking about this backwards. If our current location is greater than, the distance to our owner is greater than 500, we need to find, I clicked the button again. We need to find a new location around our owner. Okay, and let's change this down to about 200. And then what we will do is we will set, and we'll draw a debug circle. Okay, if not, let's do this. Let's draw, if not, we're going to draw a debug sphere. And we're going to draw a debug sphere that is red for where we are. Okay, let's just see if we're even heading this. And where we are is the current actor location. Here's my concern. I have a feeling the current actor is the controller, not the pawn. That's my guess. Let's see here. Okay, so there's blue. There's blue. Okay, we are not... Something's up, y'all. Because I see no red spheres. Find random location by owner. The distance is greater than 500, it draws blue. If it's not, it draws red. And the controlled pawn is here. That's the actor location. Okay, some more debugging for us. Oh wait, hold on a second. Let's change our radius and make sure we're not drawing circles on top of circles here. Yeah, we're not. We're definitely within 500 of that at that point. Okay, so that's not it. Let's try. Actually, you know what? Let's try 1,000 just to be sure. Oh, I pressed pause. Yeah, there's no way. Okay, so how are we going to debug this? Because we can't end the stream without at least debugging this. So what we're going to do is we're going to draw some more spheres. So let's draw a debug sphere. And this one, let's make it a different size just in case we're drawing on top of each other. Let's go with 55. And we're going to make this green. Okay, and what we're going to do with this green is we're going to draw this every single time for a duration of 1 and a thickness of 1, so we can see where it thinks this actual actor is. Compile and save. So that's our first step. So that's where the green sphere is. Look at where the green sphere is. You see it? That's our problem. Okay, so the actor, my guess was right. Our actor is actually an AI controller, and what we need is we need the controlled pawn. So can we get this without doing any kind of casting? Let's do this. Let's cast this to an AI controller, and with that we can now, I'm going to go leap of faith. I believe this is going to work. And with that, we're going to get the controlled pawn. We're going to get the controlled pawn, and with that, we're going to get the actor location. That's what we're going to use instead. Is everybody with me? So we're not even going to draw the green circle now. All right, fine. I'll draw the green circle. You all convinced me. Good job. Here we go. So green circle, red circle. Great. Now, see how it's going flying off into nowhere? Where's he going? Come back, little buddy. Okay, here's the problem. So that's just what I thought was going to happen. We can actually reduce our radius again, back down to, let's say, 500. And what is happening is, the minute you see the red sphere, I'll answer your question in a second, Mr. Ren. The minute you see the red sphere, what has happened is this entire task has failed. but we didn't tell it that it failed or it succeeded. So we left our AI in this weird state. So watch what happens. When we come in, it's going to get to the blue spot. Then you'll see red. And now if I move, nothing happens. We've left our AI in a state of unknown. It is actually stuck inside of this behavior tree task, find random location. So this is why it's really important that you finish your executes. So what we're going to do is we are going to, even on false, and even on a failed cast, we would want to finish our executes, for example, or have some kind of error checking as a result of that. We can get rid of our green spheres now. We have our pawns. We have all this stuff. This looks good. Let's clean this up a little bit now that we have all that in place. We have our finish execute. So that should no longer happen now. So what should happen now is once they move in place, they'll chill. Okay, which is what we want. That's what we wanted. And now when I move, they should update to come back and move to where I am. Everybody with me? Okay, now to answer Mr. Dirty Daniel's question, you can't drag off the original actor location node and get the pawn there. Okay, so actually, the original actor location node here, when I was getting the location, this was getting the location of the controller, not the controlled pawn. They're not in the same place. So the visual of our character was somewhere else in the world versus where the controller was controlling it from. So that's why I couldn't just drag off of there. I needed to get the controlled pawn and then get the location from that. Now, interestingly enough, I believe there is another execute. Execute event AI. I think it's received. Okay, yes. So there is another event that you can use in behavior tree tasks called event receive execute AI. Now, in this particular case, theoretically, we could just plug this into the actor location instead, and we would not need to do our casting because this is getting our controller, and then our controller was not being used for anything. Now, the reason I chose the other one, okay, this may work because we already have the pawn available here. Okay. However, the reason I chose this one is sometimes I've had problems with this one. So let's just see if it works. It may just work. Seems to work on this one, which is great. So just know that there are two of them. Let's see if we can mouse over these. This alternative AI version receive. Oh, depending on which one's implemented, it will do. Yeah, so technically we could just do this. We could get rid of the casting, clean this up a lot. That seems to work. We can get rid of our debug sphere now and all of that. And here we go. There we go. Compile and save, press play. Okay, so now our drone actually flies in, turns to kind of face where we're at, and then depending on where we go, it will fly to join us. Turn the corners, etc. Now, what we are going to do next time is we're going to make this drone a little bit smarter, and what we'll do is we'll have it so when it comes to join us, we can have it face us, face the same facing. We're going to make it so that it can attack. We're going to potentially look at the issue right now. You'll notice that the drone doesn't actually update to follow me until I move. Also, depending on where I move to, it will move right through me and chop off my head and bounce off of me when it moves. So there's a couple little like detail things that we want to cover when we get into our next stream, just to make this a little bit smoother. Now, keep in mind, the way that you implement a drone is different than you would a dragon or something else, because remember, our drone can go vertical without a problem and it can turn in place and do all those things. A dragon can't really do that. So a lot of like the nuance of how the banking works and all those kinds of things might be different for a dragon. Also, elephant in the room, let's go back to this real quick. I want to show you the other thing that we're going to have to address. So in addition to addressing like how the drone picks where it's going to when it's idling and where it's going to get attack positions from and everything, the other thing that's important to note was, remember, we can control this drone. We can press F and take possession of this drone and fly it around ourselves. But when we do that, we now have a problem. Our drone is fighting us. Our drone is fighting us because in our blueprint, pet blueprint, what's happening is we're possessing our drone, and on tick, we're updating its input vectors. So the input vectors we're giving it as the player when I want to control it versus what's happening on tick. Here I can show you just as a recap. If I press play, if I press F to possess our drone, I can now fly the drone however I want to get it to where I want it to be, right? Remember, we could do this. So we can make it go up and down. But while it's possessed, we can't have tick updating the input to override our input. So we're going to need to be doing, we're going to need to basically on tick, put in a check to see if we're possessed or not. And that is going to come into a bunch of this, is the pet possessed, etc. And one of the things that we're doing, and we may use a variable for that, or I'm not sure, but overall, those are some of the things that we have to do. Charles, welcome to the stream. So can you address concurrency before the stream ends? What do you mean by concurrency? Is that what you're talking about? Like the fact that we are concurrently possessing and driving it at the same time? Yes, Konami code and idle one. Basically, you'll be able to expand. Like once you have MoveTo down in your behavior trees, how you decide, like basically at that point, it's literally just AI setup. It's like you can have a patrol mode, you can have an attack mode, you can have a rest mode, whatever it is you want. And then in your behavior trees, wherever you set that MoveTo, that's where it's going to go to. And then what it does when it's there will be controlled by your behavior tree or however you want to do that. So, does anybody have any questions? We ran a little bit long today. That's largely because I lost all of my notes, but we recovered, which is cool. So if there aren't any questions, as always, I've been working on learning this stuff lately. It's super confusing when you're not familiar with it. You're welcome, Josh. No worries. So, as always, don't forget to check out all of our streams. All of our live streams are in the live section of the YouTube. We also have the stuff that happens each week. Again, best part about doing this is the community. Thanks for all of your support and help. You know how this works. Help spread the word. Let people know what we're doing if you dig it, so we can keep on doing it. And I will see you all in the next stream. Charles asks, NPC. Okay, hold on. When more than one BT references the same actor. I guess I've never had that problem, Charles. I generally, my behavior trees for enemies fighting enemies has always been the enemy picks a target, and there's all kinds of target prioritization from that. Based on target priority, they choose who to attack. And as far as when more than one behavior tree is used for the same actor, they're not technically. Each actor has its own instance of the behavior tree that's running it. I'm pretty sure it's so that, yeah, it has to be, because otherwise every single enemy would move to the same random location otherwise. So just by doing that, you can do that. But also, to Mr. Dirty Daniel's point, as part of the wrap up, don't forget we do have the Discord and Patreon links in the description below. Hop in Discord. The community is really good about helping each other out, answering questions. I hope you all have an awesome weekend. Keep an eye out. The IK control rig is coming. So we've the FK control setup. Forward Kinemax is being released this week. Inverse Kinemax will be released to Patreon, should be this week. And we're just going to keep rolling through the control rig stuff as well. So Anubis, thanks for hopping on the stream. Charles, Mr. Dirty, PBM, Off the Rails. It was good to see you all. Josh, thanks for chiming in. I'll catch you all on the next one. Sweet. Later.